Welcome to the solutions for the transformation worksheet. Before I start these, I'm just going to have a quick overview of the transformations because people get very confused about them. It's pretty straightforward. At GCSE there are two types of transformation. There are stretches and there are translations. And stretching is all about multiplying or dividing, and translating is all about adding or subtracting. Now, each of these can happen in two directions. So they can either happen in the x direction, that's left or right, or they can happen in the y direction. That's up or down. Now, you can distinguish them. X direction things happen inside brackets, and y direction things happen outside. So, there's basically four things to learn. Now, stretching in the x direction would look like this. You'd have your function, and inside the brackets you'd have a number, which I'm going to call a, times your x. In the y direction, you'd have your function of x, and the whole thing would be multiplied by a. Notice it's outside the brackets. Translating, you'd have your function, and inside the brackets you would have what you're adding to it. In the y direction you have your function, and you would add to it. Now, what does this actually look like in practice? Let me just give you some examples. Now, here's an example of a translation. So, this is the cubic function in blue, and I'm going to show you what happens when you add things to it. Now, if you just add something to the cubic function, then you get the cubic function add a number, and that's b. So watch what happens. This is outside the brackets, it's going to be in the y direction. So you can see it moves it up when it's positive, and when it's negative it goes down. Now, inside the brackets, that's my a, that is, and that's going to translate it in the x direction. And this is a bit odd because when you have a positive number for a, so a is currently 2, you can see it's moving left, and when it goes negative it's moving right. And of course you can have a combination of the two to move it any way you like on the graph. So notice that the shape does not change, it's just it moves. Let's have a look at the stretch. So I've got two functions here. I've got the cubic function here, and I've got the quadratic function here. So let's start with the quadratic function. So if I adjust this, it's going to stretch it in the y direction. Now, notice that it's getting longer and thinner. Imagine you had a hand down here and a hand up here, and you pulled your sheet of rubber paper and it would stretch, it would get long and thin. So the bigger the number, the longer and thinner it gets. And the smaller the number, the fatter it gets. A bit like drawing a picture on a piece of elastic band and pulling it. But notice that the points on the axis don't move. And the same is true if we look at the red one. So you can stretch it. I've got my step set to, there we go. Okay. And again, notice that the thing is moving up and down. It's being stretched up and down, but the point on the axis remains where it is. And that's a stretch in the y direction, and the x direction is similar. Anyway, let's go and have a look at the questions now. So, question 1. Some random little marks around it. Here we go. So we've got our shape now. Hopefully you recognise this as the as a sort of quadratic graph, although we don't know the actual equation. We're just told it's called f of x, and we're told about this point here, and we're also told about this point here. We know it's 0, 0. So, write down the coordinates of the maximum point of the curve with equation y equals f of x minus 2. So this is the thought process. It's adding or subtraction, which means it's a translate. It's inside the brackets, which means it's in the x direction. And you could write that as It's also inside the brackets, so the negative means it moves right, so it's going to be 2 right and nothing up or down. So the whole thing is going to move 2 right, which means that the point here is going to be, instead of 2 along, it's going to be 4 along, but since it's not moving up or down, it still has a y-coordinate of 3. Now the second question, 2f of x, so it's a multiply, which means it's a stretch, and it's outside the brackets, which means it's in the y direction. Now, how far does it get stretched? Well, it's basically going to be doubled. Everything's going to get doubled, but not the points on the axis. These stay exactly where they are, so the x-coordinate isn't going to be changed because we're stretching it in the y direction. So the 3 is going to be doubled to become a 6. Okay, next question. So we're told that this is our f of x, so it's another quadratic curve, and the only vertex is at 1, 2, so that's the point that we're told about. Write down the coordinates of the vertex of the curve with this equation. So where does this end up? Okay, so this is an add, which means it's a translate. It's adding, it's outside the brackets, which means it's in the y direction. And in the y direction, everything happens normally. Plus 3 means it's going to go up 3. So the answer is going to be 1 along. But it's not going to be 2 up, it's going to be 5 up because we've added 3. And you'd write this as a translate of 3 up. Okay. This one, it's the same as the last one, isn't it? It's a translate. It's inside the brackets, so it's in the x direction. And it's, because it's in the x direction, it's reversed, so minus makes it move right. So it's 2 right, 0 up, which gives us 3, 2. Now, the curve with equation f of x is transformed to give the curve with equation y equals minus f of x. So what happens here? Well, what we've basically done is all the y-coordinates have become negative, which means all the negative ones have become negative, negative, positive. The whole thing's been flipped. It's been reflected. So it's a reflection in the x-axis, or y equals 0. There we go. Okay, so we've been given a graph and we're told to sketch a graph of f of x minus 4. So this is a add or subtract, which means it's a translate. And it's outside, so it's in the y direction. And it's 4, so it's 4 down. Now the way to sketch these is to look at the points they've given you and move them. So we've been given this point here, so we can move that 4 down, it's going to go to there. We've been given this point, we can move this 4 down, it goes to there. Notice the slightly misleading graph scale, that's going to go down. And we've also been given these points, they can go 4 down as well. So, let's see how this works out. Dodgy sketching on a computer. That's dreadful, isn't it? Cool. Don't do it like that. And it's moved for us as well. Let's see if we can put it down. There we go. That's got to be one of the most dubious curves I've ever sketched. Blame the graphics tablet. Okay. Right. So now, on the next grid, we've been asked to sketch a graph of y equals f of a half x. So let's just decide what that is. So what's f of a half x? Well, first of all, it's a stretch, and it's inside the brackets, which means it's in the x direction. Now you would expect a half to make it half the size, but everything when it's inside the brackets happens the wrong way round, so it's going to be doubled, so it's a scale factor of 2. So we're stretching in the x direction, which is this direction. Everything on this line here, the y-axis, is going to remain stationary, so that stays where it is. Everything else gets doubled. So this point stays where it is, and these points are going to get stretched. Now this is 2 away from the y-axis, so if we double that, it's going to be 4 away. This is minus 2, so it goes to minus 4. and similarly these get stretched out as well. Maybe I'll have better luck sketching this curve. Here we go. Right, so it's going to go up here to there, over the top, back down to there. There we go. So you would expect a half to make it smaller, but stuff that happens inside the brackets always happens the opposite way to that you'd expect, so a half actually makes it stretch out. Okay, right, and the challenge question. So, seems quite a tricky question. Let's have a look at this curve first of all. If you expand the brackets, you get y equals x squared minus 4x, which tells us it's a U-shaped, it's a quadratic curve. So let's actually sketch the curve first of all, the curve C1, before we work out where the C2 curve is. So here's the C1 curve. Now, to sketch a quadratic, we ideally want it in factorised form, which is what they've given it to us in. So there's two solutions here. We've got 0, so that's one crossing point on the x-axis. And the other crossing point is 4, because 4 minus 4 is 0. So 4, so I'm going to put that there. And it's a U-shaped curve, which means it comes down here and goes back up there. That's curve C1. Now, C1 is mapped to the curve C2 by the translation minus 2, 0. So minus 2, that's the x part of it, so it's minus 2 along, so it's going to move that way 2. So that means that's going to end up over here, and this one's going to end up here. There we go, that's curve C2, which means that the answer is pretty obvious now. Find the coordinates of the point where the curve C2 cuts the x-axis. And the coordinates of the point, I'm going to do it in a different colour, are minus 2 along, 0 up, and 2 along, 0 up. And there we go. Hope you found it useful.